Alright, next problem is 13.62, and this was kind of like a work energy problem. It says how much work is required to launch a spacecraft of mass m and place it in low circular orbit, ignoring the kinetic energy that the craft has on the surface due to the Earth's rotation. So, like I mentioned before, this is kind of related to the work energy theorem, which is work is equal to kinetic energy 1 minus kinetic energy 2 minus kinetic energy 1, or the change in kinetic energy. But we're told to ignore kinetic energy in this problem. So what we can do is just say that this is equal to the change in overall energy itself. And we know that the energy of a low orbit is equal to the negative of your gravitational constant times the mass of Earth times the mass of whatever it is that you're launching the particle times 2 times the radius of Earth. And it's 2 times the radius of Earth because you just assume that low orbit is right around the value of the radius of the Earth. Okay, let me just draw a picture here actually. So low orbit, you have the radius of the Earth right here, and the orbit itself is equal to the radius of the Earth, is kind of the idea behind this whole little thing right here. So that would essentially become 2 times the radius of Earth, or the diameter of Earth. But we just use 2 since radius is the radius of the Earth is a pretty common constant. So now we have that out of the way, and we know that the energy on the Earth, our starting energy, is just going to be the gravitational constant times the mass of the Earth times the mass of our particle divided by the radius of the Earth. Alright, so now we can just plug these in here. And we have the negative of the gravitational constant times the mass of Earth times the mass of our particle divided by 2 times the radius of Earth. And then we have, this is a negative here too since gravity is pulling you down. But anyway, so then we have minus for the difference here, and negative, again because the force of gravity, the gravitational constant times the mass of Earth times the mass of our particle divided by the radius of Earth. So this becomes plus here, minus, when you subtract a negative you add it, and then we want to get, just from basic algebra here, we want to get our denominators the same, so that becomes 2, just multiply by 1, so 2 times the gravitational constant of times the mass of the Earth times mass of our particle, and then since we're adding that to a negative, we basically just subtract the 1, and that gives us that the work done to launch this particle is going to be equal to our gravitational constant times the mass of the Earth times the mass of our particle all over 2 times the radius of the Earth. Yeah?